there, you lost your cell phone. That was really silly of you. So now you got to communicate with people at home to ask for a ride home, but you have no phone. So how do you do it? You can't possibly shout loud enough for them to hear you, but you do fortunately have a pedal-powered sound machine. Using your lake power, you can transform all of your lake power into the sound of sound, thereby sending a distress call to your home. So the question is, what will be the intensity of the sound when it gets there? So, in my case, I can produce up to 910 watts of power using my legs. But my home is, unfortunately, 12 kilometers away, which is 12,000 meters. So, what will they be able to hear at home with my device? So, if you'll remember, intensity, we have a formula for intensity. Intensity, letters, equals power divided by the area of the surface area of the sphere, because this sound is going in all directions. It's radiating outward like a big sphere of sound. So the formula is 4, that's 4, pi r squared. Talk it cheap, let's do math. Okay, so I'm going to shorten this to I because I know how to spell I. My power is 910 watts, 4 pi, and then R is 12,000 meters, and the whole thing is squared. So, doing a little math. I did the math before I came up here. Okay, I is equal to 910 watts over 4 pi is 12.566 blah, 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 blah. It doesn't matter. 12,000 squared is actually quite easy. 112 times 12 is 144. 1,000 times 1,000, well, just twice that many zeros. 1, 2, 3. 1, 2, 3. We get 144 million. Now, meters are also squared. Meters squared. All right. Well, let's just do it. Now, fortunately, I have a calculator because doing this kind of long ways, it takes a while. So you multiply them together, and I get I is equal to 910 watts over the area of this. I mean, think about it. This is a very, very large sphere. The radius of the sphere is 12 kilometers. It's big. It's big. It's really big. So let's work on it. So I get an area of 1.809 billion. And if you want the actual change here, 557, and whatever. That's what it is. That you don't need to worry about it. Now, divide them, and when I divide them, I get an unbelievably small number. I get 0.0000005 502 885 blah 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 blah. Now, where to round? Well, first off, I want to put this in scientific notation, so it's going to be 5 point, decimal goes after the first significant figure. Now, where to round it? I have 2 sig figs. I'm going to round it to 2 rounds down, and that becomes a 0. So let's figure out what the exponent is going to be here. So let's see. In order to get here, how many places do I have to move? 1, 2, 3, 4, 5, 6, 7. So it's the negative 7. If you're wondering whether it's positive or negative, negatives are really small things, positives are really big things. So it's the negative 7. So 5.0 times 10 to the negative 7 meters squared. Oh, sorry. Woo, boy, big mistake. Let's see, watts was on top. So watts per meter squared. That is the intensity of the sound waves. I hope my wife is listening, because it's not going to be all that loud, but I'll try. Here we go. Oh, quickly, what do you think your answer is going to be? Now, things to think about. If you're not as powerful as me, your value for P will be smaller, and that would make your number smaller. But, I think that your power is going to be much closer to my power than your distance is to mine. I live in Monrovia. I'm moving a much further away, so my number is probably a lot bigger than yours. And then you can take that, you combine the fact that it's squared. So chances are, this sphere that the sound is going to spread out over, for you it's going to be so much smaller. Smaller, which means that your number is probably going to be a lot bigger than mine. So 10 to the negative is going to it's almost certainly going to be 10 to the negative something, but probably much bigger than mine. We're not talking millionths of a watt every square meter. So anyway, happy trails. I hope my wife gets this message.